Good morning. Here are the problems for the warm-up for today. This should be reviewed from last week and from the last unit, so take a minute or two and do these problems. Pause this here so you can do it. Okay, let's talk about these. What is the vertex? These are all in that form. Y equals a times x minus h squared plus k. So what's the vertex here? -4. We're not adding anything here, so -4 is 0. Vertex here, 2, -6. Vertex here, -3, because remember it's the opposite of what's inside the parentheses, and then -3. Here, this one has nothing being added or subtracted inside the parentheses, so that's 0. Outside the parentheses is a 4, so it's 0, 4. Axis of symmetry, remember, is simply the x value. So x equals -4. X equals 2. X equals -3. X equals 0. All right, today we're going to talk about different ways to solve quadratic equations. The first way is with the graphing calculator. Make sure you've got a graphing calculator and set your window to the following so that it matches mine. If you have additional things on the screen, don't worry about it. These are the things that you need to have. So the x-min needs to be -10. The x-max needs to be +10. The x-scale, how we count by, is 1. The y-min is -10. The y-max is +10. And the y-scale is also 1. You may have some other things here, but you don't need to worry about that. Make sure, though, when you're doing the negatives here on your graphing calculator, that you use the negative key next to the enter key, not the subtraction key. Has everybody got that? All right, let's talk about graphing. So we're going to use a graphing calculator to see where the equation crosses the x-axis and find our real solutions, if any, of each quadratic equation. So we're going to graph this first one together. So remember, hit your y equals key, and then x squared minus 2x. This is my y. I don't need to put this in. This is what you want to put into the y equals. Now, what does that graph look like? It looks like that. What we're looking for is where it crosses the x-axis. It crosses the x-axis at 0 and at +2. So x equals 0 is one solution. X equals 2 is another solution. So let's go back. Put this one into your graphing calculator. Pause it here so you can do that. Make sure you've got the x squared minus, use the subtraction key, 2x plus 1. What does that graph look like? It looks like that. Where does that cross the x-axis? Right here at that point when x equals 1. So there's only one solution to this one. It only crosses the x-axis at one point. Now let's go back and look at C. Again, this is my y equals, so I'm putting this information. X squared minus 2x plus 2. It's very similar to this one, so you can even just change the +1 to +2 for this. What does that graph look like? That looks like this. Where does it cross the x-axis? It doesn't. So there are no solutions for this one. So that's the first thing we're going to do today, is the graphing. Would you please put this in your notes? So pause it here so you can get that in your notes. When solving by graphing, the solutions are where the graph crosses the x-axis. When solving by factoring, the solutions are the values of x that make the equation equal to 0. Again, pause it here so you can get those in your notes. We have two problems. I'd like you to try these two problems. Remember, that's my y equals. So take a look at this one. When you plug that in, what do you get? All right, when you plug that in, what do you get as your solutions? You should see that it crosses the x-axis. That it crosses the x-axis here at -2 and here at +3. So my two solutions are x equals -2 and x equals +3. Now, let's take a look at this one. Is this set up as y equals or 0 equals something? No, it's not. So we have to subtract the 4x from both sides first. Now, can I subtract the 4x from the 2x squared? No, because those are not the same variable. And I can't subtract these two either because this has a variable and this doesn't. So this cancels, so this gives me 0. -2x squared minus 4x minus 2 equals 0. So something you might want to put in your notes is if the equation is not set equal to 0, you must solve it You must set it equal to 0 first. And that's true regardless of how we solve these. So put that in your graphing calculator and see what you get. You get one place where it crosses the x-axis, so x equals -1. If I were to plug a -1 in, -2 times -1 squared minus 2 should equal 4 times -1. Well, -1 squared is 1, times -2 is -2. -2 minus -2, 4 times -1 over here is -4. -2 times -2 minus -2, or minus 2, is -4. Does -4 equal -4? Yes. So that is my one solution. All right, we're going to pause this right now. You're going to do these two problems. We'll give you about 5 minutes to do these in class using your graphing calculator. When you're finished with your graphing calculator, clear your equations out and put it back for me, please. All right. Another method is to solve using square roots. If you notice, we're going to only solve using square roots. We're going to use this method if there is only a squared term. If I have 4x squared and an x term in here, I am not going to use this. To do this, we want to get the squared term by itself. And then how do we undo squaring? We're going to take the square root of both sides. Okay, so let's take a look at this first example up here. Pause it if you need to get these in your notes. What's with the x squared that we need to get rid of? We need to move this plus 31 or minus 31 first. We do that by doing the opposites. We're going to add 31 to both sides. So I get 4x squared equals 80. I'm going to divide both sides by 4. So I get x squared equals 20. Now I have the x squared by itself. So now I'm going to take the square root of both sides. So we'll get x equals, now remember when we take the square root of a number, the positive answer and the negative answer are both options. So our answer would be plus or minus the square root of 20. But we're not done here because we need to ask ourselves, does this equation break down? Or excuse me, does this number break down? Yes. I can break that down into 4 and 5 and 2 and 2. The 2 comes out, still plus or minus 2 times the square root of 5. That is my answer. All right, let's take a look at this. You try this middle one for me. 3x squared plus 9 equals 0. Pause it here so you can try it. All right, so what you should have done here was subtracted 9 from both sides first. When I do that, I get 3x squared equals negative 9. Then I'm going to divide both sides by 3. I get x squared equals negative 3. To solve this, I would take the square root of both sides. However, can we take the square root of a negative number? No, we can't. So the answer to this one is no real solutions. Okay, now let's take a look at this one. This one's a little different. We've got a few things to do before we can take the square root, and we're going to have to think about what happens over here. So when we're doing this problem, go ahead and write this problem down in your notes. When we're doing this problem, we have to get rid of this squared before we can worry about what's inside the parentheses. So we have to move this 2/5 first. I can divide by 2/5, but dividing by a fraction is the same thing as multiplying by its reciprocal. So if I multiply this side by 5/2, I have to multiply this side by 5/2. My 5's are going to cancel, my 2's are going to cancel, and I'm left with x plus 3 squared equals 25/2. Remember, this is 5 over 1, so we just multiply our numerators, multiply our denominators. Now the squared term is by itself because this x plus 3 is in parentheses, and it has to stay together until we're done. So now I'm going to take the square root of both sides. Taking the square root of something squared leaves us with what we started with, so x plus 3. This is the square root of 25 over 2, but remember it's plus or minus. We can write that as plus or minus the square root of 25 over the square root of 2. We can break those apart. 25 is a perfect square, so plus or minus 5 over the square root of 2, but what's wrong with this answer? Right, we can't have that radical in the denominator. So in order to get rid of it, we have to rationalize it. We have to multiply top and bottom by the square root of 2. So we have plus or minus 5 over the square root of 2 times the square root of 2 over the square root of 2 equals plus or minus 5 square roots of 2 over 2. But that's what x plus 3 is equal to. We have to solve for x, so we're going to subtract 3 from both sides. That's going to cancel here, leaving with x equals plus or minus 5 square roots of 2 over 2 minus 3. I can't subtract these anymore or simplify these anymore because this has a radical, this does not, so that can't be combined. Sometimes in math what we do is rewrite the real part first, so the negative 3, and then we say plus or minus, and we do the irrational part second. Either one of those would be the acceptable answer. All right, So I would like you to try number 5 and number 6. Pause it here so you can try those. Okay, let's talk through this answer. First thing you should do is subtract 1 from both sides. So you get negative 2x squared equals negative 7. Then you're going to divide both sides by negative 2, leaving you with x squared equals 7 halves. Now I know a lot of you would want to write that as 3.5, but we don't like taking the square root of a decimal, so we're going to leave it as 7 halves. Notice that our negative signs cancel each other out, so we do have a positive answer. So when I take the square root, I end up being able to take the square root. So I get x equals plus or minus the square root of 7 halves, which is plus or minus the square root of 7 over 2, square root of 2. Can we leave it like that? No, so we should have plus or minus the square root of 7 over the square root of 2, and we have to multiply both top and bottom by the square root of 2. Remember, we can multiply under the radical, so I get plus or minus the square root of 14. Here, square root of 2 times the square root of 2 is 2, and that would be my answer. Now, let's go back and look at this one first, or next, excuse me. Again, we have to get the squared term by itself, so we're going to divide both sides by 2. So I get x minus 4 squared equals negative 5 halves. So now I'm going to take the square root by both sides. However, I can't take the square root of a negative number, so there are no real solutions. Questions? Okay, the next thing we're going to talk about is factoring, solving by factoring. We've been talking about factoring, and that's why we did that, was to get this set up so that you would remember how to do that. Would you write this down in your notes? We have the zero product property. It says if the product of two expressions is 0, then one or both of the expressions equals 0. Or if A and B are expressions and A times B equals 0, then A equals 0 or B equals 0. We saw that back when we looked at this format. This was our intercepts format. Remember, this is where it intercepts the x-axis. Those are our solutions. So if I had a problem like this, y equals 5 times x minus 7 times x plus 3, if we wanted to know our solutions, we would set it equal to 0. So 0 equals 5 times x minus 7 times x plus 3. But in order for this to be 0, either this or this has to be 0. And so that's why we did this. This x minus 7 equals 0, or x plus 3 equals 0. And we got x equals 7, and x equals negative 3. Those were our intercepts. But remember, we said earlier that our intercepts are where it crosses the x-axis. All right, let's take a look at a few examples. All right, write this problem down. We're going to solve it by factoring. X squared minus 4x equals 45. Now, turn to your side partner and talk about what you think you need to do first. Right. First thing you always have to do, you have to set equal to 0 before you can factor. So what are we going to do first? We're going to subtract 45. Those are going to cancel. It's going to give me x squared minus 4x minus 45 equals 0. Now this is what we dealt with yesterday. So we're going to identify our A, our B, and our C. A is 1, B is negative 4, C is negative 45. Remember, we take A times C, which is going to give me a negative 45. And I have to come up with something that multiplies to give me negative 45 and adds to give negative 4. Think about that. What do you think that is? Right, negative 9 and a positive 5. So we're going to do that split the middle like we did yesterday. Remember that x squared doesn't change. The minus 45 at the end doesn't change. But now we have this equals 0. This minus 4x is going to get split into negative 9x and plus 5x. And then we're going to factor by grouping. What can I take out of here? X leaves me with x minus 9. What can I take out of here? 5, which also leaves me with x minus 9. Taking that x minus 9 out of both of those terms gives me x minus 9 times x plus 5 equals 0. Now, this goes back to that 0 property. If I have two things that I'm multiplying together and it equals 0, that tells me either x minus 9 equals 0 or x plus 5 equals 0. Solving, I add 9 to both sides, and I get x equals 9. Solving here, I subtract 5 from both sides, and I get x equals negative 5. So we can see we have two solutions, and if you notice, it's the opposite of what's in those parentheses. If you can go from here to here, that's fine, but this is where that's coming from. Okay, write this problem down. Find the zeros of f of x equals 2x squared minus 11x plus 12. Finding the zeros is just another way of saying find the solutions or solve. If we're going to solve, we're going to set it equal to 0. And so again, we do our A, our B, and our C. A is 2, B is negative 11, C is 12. I want you to try to set up how you factor that. So pause it here so you can do that. Okay, so 2 times 12 is 24. Whoa. 2 times 12 is 24. What multiplies to give you 24 and adds to give you negative 11? How about negative 3 and negative 8? So we split this middle term. The 2x squared stays. It's still equal to 0. We can't lose that. Then it becomes minus 8x and minus 3x. And then that plus 12 stays. And then we factor by grouping. I can take a 2x out here, leaves me with x minus 4. I can take a negative 3 out here, which leaves me with an x minus 4 as well. And that's still equal to 0. So 0 equals, taking that x minus 4 out, we're left with 2x minus 3. Now, because this coefficient is a 2, we have to actually set this up and solve this. We can't just say it's positive 3 because we've got to set it up and solve it. If x minus 4 times 2x minus 3 equals 0, either this is 0 or this is 0. So either x minus 4 equals 0 or 2x minus 3 equals 0. Solving here, I get x equals 4. That's one solution. Solving here, I'm going to add 3 to both sides. Divide both sides by 2. And I get x equals 3 halves. Or in this case, if you wanted to call it 1.5, you could. So those are my two choices. All right, would you try this one? And this one. Pause it here so you can try those. Think about what you have to do first. Here, what you have to do first is you have to subtract 2, because it's got to be set equal to 0. Remember, I can't subtract these because this has an x and this doesn't. So A is 3, B is -5, C is -2. A times C is -6. I need to find something that multiplies to give me -6 and adds to give me -5. Well, -6 and a +1. So again, I'm going to split that middle term. 3x squared minus 6x plus x, or 1x, minus 2. Look for a GCF here. We can take a 3x out. We get x minus 2. Look for a GCF here. There's nothing, so we take a 1 out, and we get x minus 2. So we have x minus 2 equals 0. X minus 2 times 3x plus 1 equals 0. So either x minus 2 equals 0, or 3x plus 1 equals 0. Well, if I solve this one, I get x equals 2. If I solve this one, I'm going to subtract 1 from both sides. So I get 3x equals -1. Dividing both sides by 3, I get x equals a -1/3. And there are my two solutions. Now, on this one, you could have done A, B, and C, but when you do A and C, you get 0. And so that makes it pretty tricky. What do you notice first here, though? What could you do first? Right, there's a GCF for those. So I get 0 equals, because remember finding the zeros means set it equal to 0, x times x minus 8. Again, if I'm multiplying two things, either the first part is 0 or x minus 8 is 0. Well, if x is 0, that's solved. If x is minus 8 is 0, if I add 8 to both sides, I get x equals 8. Those are my two solutions. Okay, so I would like you on a half sheet of paper. If you need a half sheet, we can give you a half sheet. If not, take out a piece of notebook paper that you can turn in. Explain what method you would use to solve each of these following quadratic equations and why you chose that method. You do not have to solve it, but would you solve by graphing? Would you solve by using square roots? Or would you solve by factoring, and why? When you're done with that, this is your homework for tomorrow. On page 99, 13 through 18, 23, 24, and 27 through 33. Have a good day, and I'll see you on Friday.